Hello students, welcome to classroom. In today's video, we will be discussing about dispersion of light through a prism. In the previous video, we were discussing about refraction of light through a prism. Now this is the topic immediately after refraction of light through a prism. So this is going to be super interesting because through here you will learn so many things. Okay, this chapter will open your wisdom to a bigger picture. So I assure you that this is going to be interesting and then you will learn a lot. So keep watching and then learn. Okay, learn. I am here to teach you. So learn enough, learn so much, because learning is very important. Okay, knowledge is the biggest tool that you can carry on in your life on earth. Okay, no other tool is as powerful as knowledge. So remember, knowledge, okay, is the most powerful tool. If you are knowledgeable, nobody can defeat you. Okay, so knowledge is supreme, knowledge is king. Okay, so remember, seek knowledge, gain knowledge, and the best provider and the source of knowledge is God. So always seek knowledge from God. Okay, so with this note, let us start our class today. So dispersion of light through prism. In the previous class, in the previous video, I have given you a small introduction, okay, of what a prism is. So now in today's topic, we will be using the same prism, okay, and then the topic is dispersion. So in today's class, first of all, I would like to explain to you what dispersion is. So what is dispersion? Before we go into the topic, you have to know the literal meaning of dispersion. Okay, dispersion means splitting. Splitting. Okay, now you should know the meaning of splitting. So what is splitting? The literal meaning of splitting. So just imagine that this is a stick, and then let's say I have a knife, and then I cut this stick. Okay, so this stick, I cut it into 10 pieces. So what have I just done? I have just splitted this single stick into 10 pieces. Okay, this is the meaning of splitting. In terms of light, okay, in terms of light, we will be saying dispersion. Okay, so splitting, okay, splitting is dispersion only. So dispersion of light means splitting of light. So in this topic, we will be learning, okay, how a single ray of light splits into 7 different colors. All right, so this is what we will learn in this topic. Okay, so let us continue the discussion further. So once again, I will be drawing a prism. So let us draw a prism. So triangle, a prism is a triangle, so I will be needing a triangle, and then I'll be using my scale again. So here is my scale. So this is the scale. Okay, a long scale for me. So let us draw the outline of the triangle. I need a long scale, but then I don't have a long scale, so I have to manage with this, and it's not comfortable. This is also not easy, but then I don't have anything longer than this, so I have to work out with this one. So let's see. Yesterday the triangle came out perfect, so how will it be today? Let's see. I pray that it comes out well today, just like yesterday. How is it? Let me have a view. I don't think it's that bad. It's all right. So let us just use this. Okay, class, we'll use this. So let me complete the base here. All right, so let's go like this. It has only touched the edge there. Let me bring down this and let it connect to this one. All right. Lovely. So very helpful. So this is a prism. Okay, now let's draw a ray of light. Okay, we are going to study dispersion of light. In order to study dispersion of light, we need a ray of light. Okay, a single ray of light. So let's bring a ray of light. So let this be the ray of light. So let me draw this, and I will request you, my dear students, to grab a notebook, pen or pencil, and draw along with me. Okay, so that, because that's the best way to learn. Okay, we learn that way better. So please do that. So let us draw this as the incident ray. Let this be the incident ray. So this is the ray. Now this ray, okay, this ray will pass through the prism, and when it passes through the prism, it will undergo dispersion. It will undergo splitting. Okay, so first of all, let us write what dispersion is. So let us write the definition of dispersion of light. So dispersion. So what is dispersion? The phenomenon of dispersion is the splitting of white light into its constituent 7 colors. So the splitting of white, let me underline this, of white light into its constituent 7 colors, underline this also, 7 colors, is known as dispersion of light. So what is dispersion, or what is dispersion of light? Dispersion of light is the splitting of white light into its constituent 7 colors. Okay, this is known as dispersion of light. We can also add the splitting of white light into its constituent 7 colors when light passes through a prism. Okay, when light passes through a prism, okay, is known as dispersion of light. So we can add extra 7 colors. You can add here. When light passes through a prism. We can also add this one. Okay, a slightly longer version of the definition. Okay, so the splitting of white light into its constituent 7 colors, okay, when light passes through a prism, is known as dispersion of light, is known as splitting of light. All right, okay, remember, dispersion means splitting of light. When white light, remember class, this is white. Okay, this is white light. So this is white light, WHITE. Remember, this is white light. This is white light. White light. Okay, so sunlight. Okay, sunlight. Okay, sunlight, the rays coming out from the sun is white in color. Now the reason why we see the sun to be reddish, okay, or orange, like that, okay, this is all because of the atmosphere. Okay, very soon we will be studying scattering. So when we discuss scattering, it will be very clear to you all, okay, why the sun appears to be reddish in the evening, and then why the sun appears to be white when the sun is at the noon. This is all because of scattering of light. Or else in actual reality, okay, the sun rays are white in color. Okay, and in studying dispersion of light, we will take the original form of sunlight, which is white. So we are taking white light. Okay, remember. Now this is the real color of sunlight. Sunlight is white in, okay, sunlight is considered to be white. Okay, and one fact, when all the colors, okay, travel together, okay, the colors of the spectrum, violet, indigo, blue, green, yellow, orange, red, when all of them, okay, travel together to you and they enter your eye at the same time, okay, it will be white. Okay, So this is white light, and then it will pass through the prism. Now when it passes through the prism, now let us draw, okay, how it will pass through the prism. So if the prism was not there, okay, it is very helpful to always draw this one. So let me draw this. If the prism was not there, then the ray will have passed like this. Let me just show you how the ray will have gone if the prism was not there. This is helpful. Drawing this is really helpful. That's why I like to draw this. So if the prism was not there, this is how the ray will have passed through. Okay, but the prism is there, so the ray will never pass through like this. Okay, and now it is not wrong to show this one, so you can always show this one. Okay, so now what will happen? The ray will undergo splitting. Okay, but first of all it undergoes bending. So let us draw the inside story now. So the ray will never travel like this, so let us draw it like this. So one ray, one here, one, then okay, let me draw with freehand now. So one gone there. Okay, now splitting will take place. This single ray of light will start splitting inside the prism. Okay, so I have to draw 7 more. So one gone, then 2, 3, 4, 5. Okay, then let us take 6, then let us take more, 7. VIBGYOR. So let's take one more again. Okay, we need a lot of practice. Okay, so this is how splitting is taking place. See, one single ray of light, okay, is splitting. Okay, is splitting. Now how will they emerge out? So how will they emerge out? They will emerge out like this. So here outside here, this is air again. This was glass, this is air again. So again they will bend a little bit. So one here, then 2, 3, then 4, then 5, then 6, then 7, then 8. Okay, so this is the emergent ray, and here this, okay, this will be violet, indigo, blue, green, yellow, orange, red. So this is your spectrum. This is the spectrum. This together, the band of 7 colors is called the spectrum. So will it be visible? I'll just write here spectrum, SPECTRUM. I don't know how much I have to write here, so let's just keep some space here. So this is the spectrum. The spectrum, okay, there is a question, what is a spectrum? So if they ask you what is a spectrum, remember the band, okay, the band of 7 colors, okay, the combination, the band of 7 colors, band, a group, okay, the band of 7 colors, okay, is called the spectrum. Okay, so here the colors of the spectrum are violet, indigo, blue, green, yellow, orange, and red. All right, now now there can always be a question, and I suppose this question, okay, will come to your mind, like why does light undergo dispersion? Okay, how does why are we seeing these colors? Why are we seeing these colors? Why are we seeing this spectrum? Okay, so why? Okay, why? So there's a big question, why? So why splitting? Why splitting? Okay, or how? Okay, or how also is there? How? These are good questions. Okay, why, how, when, where? These are very important questions in life we have to ask. Okay, when you ask this question, that's when you learn. Okay, so the more you ask this question, the more you learn. So how is it that light undergoes splitting? Okay, or how is light splitting? To understand this, okay, you have to see, the answer is very simple. light undergoes splitting because light is made up of different wavelength. Okay, outside here, all you see is one white light. Okay, but what you don't know is the secret nature of light. Okay, I'm using the word secret. It's not a secret anymore, but then before we discovered it, has scientists have studied, okay, and then we all considered at one point in time that maybe, okay, there is nothing in light, that light is just a ray, okay, coming from the sun. But then there was more to light, and through studies and experiment, the physicists, they found that light has got a big secret. And what is the secret? That light is actually made up of a band of 7 colors. That light is made up of 7 colors. It has got 7 different wavelengths. Together, the 7 different wavelengths, they merge together and then they appear as one single ray of light. Okay, got it? So what you see is one single ray of light, but in reality it can be split into 7 different wavelengths. So that is what you have to understand here. Okay, to you and me, this is light, but in reality, okay, light is made up of 7. Okay, here I am showing only 5 fingers, but okay, they are same. This is a single ray of light, and this 1, 2, 3, 4, 5, this 5, okay, 6, 7, 2 more fingers, let's add, they are same. So these 7 colors, they will join and give you this single ray of light, and this single ray of light can be split, okay, can be split into these 7 different wavelengths. All right, this is what you have to understand. If you understand this, you have understood splitting. So light, okay, has this nature. Okay, light is made up of 7 colors. Okay, the 7 colors is the reason why they undergo splitting. This is the reason why they undergo splitting. This is the reason why they undergo dispersion. Okay, why? Because they are light. Okay, light is not one, but it has got 7 wavelengths, and so having 7 different wavelengths, when they pass through this prism, each of these wavelengths, they behave differently. Okay, when they pass through this prism, so the violet behaves differently. Now when I say behaves differently, okay, remember here its speed is affected. The speed of violet wavelength is affected, the speed of indigo wavelength is affected, and the speed of blue is also affected, green, yellow, orange, red. Likewise, all their individual speeds are affected. And since their individual speeds are affected, and after their speeds are affected, the values are not same, so all of them are traveling at different speed, and that's why they get splitted. Okay, if all of them travel with the same speed, then we will not be seeing this wavelength, we will not be seeing this spectrum. But it is not so. These 7 colors, when they pass through this prism, violet has got a different speed, indigo has got a different speed, blue different speed, green, yellow, orange, red, they all have their different speed, and because of which, okay, we are able to split them. So remember, it is because light is made up of 7 colors. Okay, and how do we know that it is made of 7 colors? Through this experiment, okay, which was conducted by Sir Isaac Newton. So the scientist who conducted this splitting experiment was none other than the famous physicist Sir Isaac Newton. So it was him, okay, who did this experiment, and he found out that, okay, light is made up of a spectrum of a band of 7 colors. Okay, so and the reason why, okay, why light undergoes splitting or dispersion in the first place is because light is not just one color. Light is actually light is composed of 7 colors. Okay, 7 colors, which we do not see. Okay, we do not see often. We only see we only see the 7 this splitted form of sunlight during rainbow formation. Okay, and like that, mostly during rainbow formation. Okay, or also we don't see much. On a bright sunny day, when you look up into the sky, you don't see this rainbow. Okay, we don't see these colors. What you see is just the rays of light. Okay, the rays of light, and you don't see this violet, indigo, blue. No, okay, you don't see that. So sunlight, okay, light, which is white in color, when it passes through a prism, it undergoes splitting. Okay, it undergoes dispersion. Why does it undergo dispersion? Okay, it's because light is made up of different wavelengths of color. Okay, so these are the different colors, and when they pass through this prism, where their speed gets affected. So the speed at which violet travels, okay, is different from the speed at which indigo travels. Okay, the speed at which indigo travels is different from the speed at which blue travels. So since all the colors travel at different speed, what we see on this end is the colors. Okay, because they all emerge out with different angles, traveling at different speed. Okay, their angles are affected. When they travel, their angles get affected. All right, it's very simple. Okay, it is very simple. Okay, not very difficult. So here, remember that violet, okay, violet is the slowest. Okay, violet is the color which travels slowest, and red travels fastest. Okay, red travels fastest. Okay, and red has got the longest wavelength. So wavelength. So let me erase this now. Let me erase this definition. Now let us discuss about the wavelengths. Okay, the wavelengths. Now, of these 7 colors, the violet, indigo, blue. So violet, indigo, blue, green, yellow, orange, and red. Okay, violet has got the lowest wavelength. Now wavelength. The topic is wavelength. Okay, we are talking about wavelength. Okay, so wavelength means the length of a wave. Okay, one crescent, one trough. This is called one wavelength. Okay, one wavelength, lambda, represented by lambda, LAMBDA. I'm not sure whether this spelling is correct, but I have been writing it, so I'm just writing it here also. So lambda. Okay, so it's drawn like this. Okay, so red has the longest wavelength, so the wavelength of red is greater. Okay, bigger. Or yes, we can write like this, bigger. Then violet has got the smallest wavelength. The wavelength of violet is very small. If I were to show you, then it can be like this. So let's go, red goes like this, and violet will go like this. Okay, so red has got a bigger wavelength, and violet, check out the wavelength of violet. It is just a few centimeters. Okay, this is just an example, and this is quite big. Okay, I'm just giving you an illustration. Okay, bigger wavelength, smaller wavelength. Okay, now having bigger wavelength, so the bigger the wavelength, okay, the bigger the wavelength, the smaller the deviation. All right, let's write down this one. The bigger the wavelength, comma, the smaller the deviation. What does it mean? Now let's go here and see. So if the prism was not there, this is how the light will have traveled, yes or no? Okay, but now the prism is there, so this is how they are traveling. Now you check out. So let's see, this is for red, and this is for violet. Check out the angle. Which angle is bigger according to you? Is this angle bigger, or is this angle bigger? First or second? Second, is it not? So this is the angle of deviation for violet. See, okay, violet deviates. Okay, the angle of deviation for violet is the biggest among the colors, and the angle of deviation for red is the smallest among the color. So red, okay, red has the longest wavelength, so deviation angle is less. The angle of deviation or deviation is less within red. Okay, and then violet has the lowest deviation, lowest level. So low wavelength, if the wavelength is short, then deviation will be high. Okay, this is just a reverse of the first statement. Larger wavelength, smaller deviation. Smaller wavelength, larger deviation. Easy, isn't it? Okay, so violet has the shortest wavelength. The wavelength of violet is short, so it deviates the most. The color which deviates the most is violet. Okay, and the color which deviates the least is red. Clear? Okay, who has the longer wavelength? Red has the longer wavelength. Having longer wavelength, red deviates less. Having shorter wavelength, violet deviates more. Okay, and so because of this, okay, these colors are visible because the colors which make up white light, okay, they have different wavelengths. When they travel through the prism, their speed gets affected, and so they emerge out, okay, distinctly outside, and that is the reason why we are able to see, okay, why we're able to see this band of 7 colors, which we call as the spectrum. Okay, so now we will go to the next topic, which will be recombination. Okay, so in the next topic here, what we will do is we will draw 2 prism. One will be like this, and the other one I will be drawing it inverted. Okay, and then let's see like what happens when we take 2 prism, one oriented normally and the other oriented opposite to the first prism. So that will be the next topic. So let's start the topic now. So here it is, the 2 prisms. This is prism number 1 and this is prism number 2. This prism, okay, this is the normal orientation of the prism, and the second prism has to be kept like this. Okay, if you keep it in any other position, this experiment will not work. So the second prism has to be oriented in this position, okay, and the first prism is oriented in this position. So this is how the prisms have to be arranged in order for this experiment, okay, to be discussed. So the topic is recombination of dispersed light. So we already know what happens, okay, in prism number 1. If a ray of light, okay, falls, if a ray of light is incident on this prism, what happens outside here, okay, emerging out from out of the prism to this end, you will find the band of 7 colors, which we call it as the Vib core. Okay, now this band of 7 colors, okay, now they will fall upon this inclined surface of the second prism, and then what will happen, okay, they will recombine again, they will emerge out as single ray of light. So basically, okay, that is the whole discussion. Okay, but let's do it together again. So with drawing, okay, so let's draw it and let's learn together in detail. So let us draw a single ray of light. So let this be the ray of light. Let's say it goes like this. Okay, so this is the white light. So this is the white light. Okay, this is white light. This white light incident on prism number A, the first prism. Now we know what will happen. Okay, so we only know the diagram. So they will undergo dispersion. So let us draw the dispersed light. Oh, okay, sorry, I have to maintain steadiness. So this is one, and let me draw the second one. So let me draw it like this. This will do, I guess. Yes. All right. Then again here, okay, here they will bend more again. So more bending will take place here. So let the rays bend a little bit. Then again, even this also. Okay, this will also bend. This will also bend. So this will also bend. And then again they will enter the second prism. So let us make it bend a little bit here again. So the ray will not go straight, but it will bend, and this is where it is. Then again this ray, okay, this ray will also bend, and then this is it, and finally the ray will emerge out the ray will emerge out like this. So this is the emergent ray. All right, so this is how the diagram looks like, class. Okay, now, so what do you suppose this light is, this color will be? This is red. Okay, this is red. Remember, this is red. This is red color. This is the red wavelength, and this is the violet. Okay, violet is at the bottom and red is at the top. So this is still red. This is violet. So red emerges out. Okay, violet emerges out. Then these colors, this spectrum re-enters the second prism. On entering, okay, what happened? Now they again undergo, okay, they again undergo, now they converge. Okay, now they will recombine. Okay, recombination of dispersed light. So with respect to the first prism, they undergo dispersion, but now this dispersed light, okay, with respect to the second prism, they will recombine again. So they will recombine again, and then they will recombine, and then once they recombine, okay, how will it emerge out? It will emerge out as white light. Okay, it will emerge out as white light. So I think this one cannot be straight. After all, bending will take place. So this is slightly error, so it cannot be straight. So let us make it a little bit like this. It will never go straight like this. Bending. A little bit of bending has been done. Like this. Okay. Yes, at least this is correct. Way better than the previous one. Okay, so this is how it will emerge out. So this is the emergent ray, which is white. So this is the white light again. So this is the topic, okay, a small topic which is very easy. Okay, once you understand what the first prism does, the second prism will do the exact opposite of what the first prism is doing. The first prism disperses, splits the white light. Okay, the second prism recombines the dispersed light back to white light. Okay, so this is it, class. This was a small topic and I wanted to finish this, okay, when in the same video as dispersion of light. So the next video will be discussing about formation of rainbow. So thank you all for tuning in, and then I'll see you again in the next video.